1410.
That's the,
Okay, it's open to everybody now. Should be. Okay, if you need to meet with your advisor this week, you want to do that to make sure that you are taking the courses you need to take. So you're nursing 1400, and then like any of your A&P, you could be in A&P 1 right now, so that you would need A&P 2 this summer, and then micro in the fall. Your English, if you haven't gotten that done, your OIS informatics course, statistics, your psych courses, any of those. Okay, so if you have any questions about that, make sure that you meet with your advisor this week to get that done. Okay. How was clinical orientation for those of you that had it? I know everybody but Morrow County had it. Is get oriented to your unit, starting to get into the computer system, maybe, hopefully.
my advisor is still Kendra. Like,
Yeah, mine
still.
is too. I was looking at the class, it still shows up as Kendra.
I can help with that. I emailed Kendra and she actually sent me a link to email them, and they changed it over to the advisor that I'm supposed to have. Yeah, so it was easy. I'll try to look for that link.
Email Kendra. I thought I had given her a list at the beginning of the semester, but you two must have fell through the cracks. Yeah. Any other questions? Okay, we're gonna start with the Kahoot from Fluids and Electrolytes. Okay, what are some functions of water in the body? What does it do?
Hydrates.
Bailey, can you think of a function?
Yeah, like cushions.
Okay, cushions. So for example, like in your joint spaces, your spinal column, okay, as amniotic fluid in a pregnant mom. What else?
It cools the body. It cools the body.
It cools the body, okay, in the form of sweating when we're overheated. Okay, how can we lose water? What ways besides sweat?
Breathing.
Breathing, peeing,
Vomiting.
vomiting. What else does water do? Marissa?
I'm trying to think of the word. Can't think of it right now.
It helps to carry vitamins and minerals and things like that through
Okay,
our
are you thinking of solvent?
That's not the word I was
Okay.
thinking of, but that's one,
But
yes.
that's a good one, right? So it's a solvent, right, for all the solutes in our body. Okay, so all the chemical reactions and all the minerals and vitamins and nutrients that we take in are the solutes in water. You were saying, Autumn?
It helps to carry things through the body.
Okay, it carries things through your body to your tissues. Okay, blood cells, nutrients. Okay, and then on the flip side of that, it also does what? Nutrients to?
Pull from.
What does it pull from? What does it pull out?
Wait.
Waste.
Good. Any questions? Serum. Serum lab, like a serum potassium or a serum sodium. Okay, that's a blood draw, and that is going to be intravascular, so this inside of the vein. Okay, when we have blood drawn, those lab values that we're memorizing and looking at, those are the values of those minerals, electrolytes in the blood. Okay, intravascular, it's a serum lab. pressure, we just talked about that. Water transports nutrients to cells and waste away from cells. True or false? True. Okay, good. Hypernatremia, the fluids are too concentrated. Hyper means too much, Na is our sodium, right, and then emia is in the blood. Okay, too much sodium in the blood, they're too concentrated. Okay, because we base concentration or osmolality off of the amount of sodium. Okay, what if something is, the concentration is equal to that of the body? That would be called what? Isotonic. Okay, and if there's too much sodium, that's called hypertonic, okay, and not enough, too dilute would be hypotonic.
And that's talking about in the vessels, right? Not in the tissues?
It could be in any space, but usually in the vessels. Okay, another name for hypovolemia is fluid volume deficit. Okay, what are some signs of fluid volume deficit in our patients? So think of our assessment. We always start with our vitals and then think of a head to toe assessment. What are some findings that we might see with fluid volume deficit?
The skin turgor is,
Okay, skin turgor is a good one, a main one.
Oh wait, never mind. I was thinking
Okay.
opposite.
They could be cold, okay, because their perfusion isn't as good as it should be because they don't have the volume to perfuse. What else?
Mouth would be dry.
They could have a dry mouth, dry mucous membranes. What else?
Capillary refills.
Slow capillary refill,
Decreased output.
decreased output. Very good. Concentrated urine, very good. Okay, what about vitals?
Lower blood pressure.
Low blood pressure? Anything else?
Increased pulse.
Maybe tachycardic, okay, because of that decreased perfusion. Okay, what about lab work? What
sodium
might-
levels will probably be low,
Okay.
potassium.
You might. I don't think we talked about this enough yet. Yeah, we did. What are the specific labs that we talked about that can show dehydration? We talked about the BUN, the creatinine. Yes?
Yes.
Yes. BUN and creatinine might be elevated. Sodium, potassium, calcium, all heavily involved in electrical impulses. Acid-base balance.
I know which one it is.
Furosemide.
Yes.
Or Lasix.
Are you the
Okay, what's
No.
digoxin for
Arrhythmia.
arrhythmia? What's Zofran for nausea? What's sodium chloride for
hydration?
hydration? Be 100%. One. Who chose metoprolol? Low pressor. What's metoprolol or low pressor for?
Blood pressure?
It's for blood pressure, specifically it's a beta blocker. Okay, potassium chloride, what's that for? For what?
I guess fluids.
That's sodium.
For like, impulse of the heart.
Okay, supplementation, if it's low. Okay, typically, what medication can make it be low?
Diuretics.
Specifically Lasix. Okay, hydromorphone or Dilaudid, do you remember what that is? Okay, it's a narcotic. So what assessments do we have to make with the narcotic?
Respirations.
Respirations,
Sedation.
sedation,
Pulse.
okay, pulse,
Cognitive.
most important one? We haven't said yet?
Pain.
A pain scale. Grand champion, Mackenzie's in third. Hannah,
It's always Josh. How are you that quick?
it's just built that way.
What kind of computer you got?
You know,
And
the
then-
whole rest of our time with him, we're gonna be like, really, Josh?
The one day that he doesn't get first, we're all gonna be like,
Now, you can't pick on somebody for not being smart enough, so you can't pick on somebody for being too smart. Okay. It's still harassment, still bullying. Okay, we don't do that. Did anybody watch the 2 10-minute nutrition videos? Only Autumn. Okay, that's good. We're gonna watch them right now. Found this guy on YouTube, and I love him. So you'll be seeing more of him. Okay, just appreciate these 2 10-minute videos. Don't try to memorize everything he's saying. There's lots of information. As far as what's gonna be on your exam, it's gonna be more high level, like more nursing interventions, signs and symptoms. That's more what we usually focus on. But it will really help you if you have a good understanding of the basics as we move forward. I think he does a really good job. So just sit back and relax and we'll watch these 2 videos. Hopefully you can hear them. Oh, that's not what I wanted.
Try online work and project calendars. Unlike traditional calendars, life calendars are
Is that loud enough?
connected to projects and tasks.
He talks kind of fast.
Reflect the most
You
up-to-date
have it, you can get to it to watch it.
and visualize and share.
I weigh about 80 kilograms. Most of that, let's say 64%, is water, though you can't tell by looking. I mean, as organisms go, I like to think that I look fairly solid. After water, the next largest proportion of me is protein, about 16%. Not just in my muscles, but also in things like the tiny sodium and potassium pumps in my neurons and the hemoglobin in my blood, the enzymes driving the chemical reactions in every one of my 37 trillion cells. And another 16% of me is fat, which I'm totally okay with. 4% of me is minerals, like the calcium and phosphorus in my bones, and the iron in my blood. And 1% is carbohydrates, most of which is either being consumed as I talk to you or is sitting around as glycogen waiting to be used. But here's the thing, it's not like I just ate 80 kilograms of food and then all this happened. Instead, my body, like yours, is constantly acquiring stuff, extracting some of it to keep, burning some of it for energy, and getting rid of the rest. But even the stuff that my body does hold on to doesn't last forever. Some of the chemicals that I absorb in my food eventually become a part of me, but enzymes wear out and membranes break down and DNA gets oxidized, so they get discarded. And then I need more of those chemicals to reconstruct the material that I've lost. As a result, over the course of my lifetime, my cells will synthesize somewhere between 225 and 450 kilograms of protein. That's like 3 or 4 or 5 separate me's just made of protein. And all the protein and fat and carbohydrates and nucleic acids that make up me, of course, come come from food. Every organism has to keep taking in and breaking down food to keep resupplying itself with the raw materials it needs to survive. And all that activity requires energy, which we also gain from food. So how do our bodies actually convert what we eat into energy and raw materials? The answer is a never-ending series of reactions that are dedicated to doing two vital and totally contradictory things. One set of chemical reactions destroys the reactants that you give them, reducing big, complex substances into molecular rubble, and the other set reassembles that rubble into new and bigger products that are put together again to make you. So our bodies are constantly reinventing themselves in a perpetual state of loss, but also always rebuilding. And even though all of this has happened at the cellular level, its consequences could hardly be larger. These two sets of reactions are where everything that we've learned so far about the digestive, endocrine, circulatory, and respiratory systems really starts to come together. Together, these processes make up your metabolism. Now, the sciencey word metabolism has come to have a meaning in popular speech, but metabolism isn't just one thing. People talk about metabolism as being like how fast your body burns the fuel in your food or how high your personal energy level is, and that's fine for use by personal trainers and fitness magazines. So physiologically, metabolism really describes every single biochemical reaction that goes on in your body. And maybe more importantly, it reconciles two conflicting chemical processes that are always simultaneously underway inside of you. One of those chemical forces is anabolism. Anabolic reactions construct things and consume energy. These are the processes that take the small monomer building blocks in your food, like monosaccharides and fatty and amino acids, and build them into bigger, more complex polymers like carbs and fats and proteins that are used in your cells. And when you need new building blocks or you need to release some energy, those polymers in your body, or new ones in your food, get broken up by catabolic reactions. The processes of catabolism break down bigger molecules and in breaking their bonds release the energy you need to stay warm and move around and provide your cells with fuel to build those polymers back up again. To be honest, your metabolism is a lot like Sisyphus. It works really hard, but it is never finished. And the boulder that your inner Sisyphus is always pushing uphill and watching fall back down, that's nutrients, the molecules that your body is forever breaking up and then rebuilding only to have them break apart again. And these nutrients, the materials that your body needs to build, maintain, and repair itself, come in 6 major groups. By volume, the majority of what we consume and what makes up our bodies is water. So that's maybe the most vital nutrient. Then there are vitamins, compounds that come in either fat-soluble or water-soluble forms. They aren't used as building blocks or for energy, but they're essential in helping the body make use of other nutrients that do those things. Vitamin C, for example, helps improve iron absorption, while vitamin K is crucial to blood clotting, and some B vitamins are important in the production of ATP from glucose. Minerals, like vitamins, don't provide fuel, but they have all sorts of other functions. Calcium, magnesium, and phosphorus harden bones and teeth, while iron is, of course, crucial in hemoglobin. Plus, potassium, sodium, and chlorine help maintain your body's pH balance and are used in action potentials. So water, vitamins, and minerals are all necessary. But the 3 major nutrients that everyone always talks about, the ones you find on food labels from oatmeal to Pop-Tarts, are carbohydrates, lipids, and proteins. Most of the carbohydrates you've ever eaten, with the exception of lactose in milk, originally came from plants. Mono and disaccharides come from fruits, honey, sugar beets, and sugarcane, while polysaccharides, starches, come from veggies and grains. The main thing you need to know is that the monosaccharide glucose is the be-all, end-all molecular fuel that your cells need to make ATP. ATP being the molecule that your cells use to drive anabolic reactions. Need to make new polymers or get anything else done, whether that's operating the sodium-potassium pump or detaching the head of a myosin filament to contract a muscle. But ATP is too unstable to store, so cells often store energy in the form of glucose, which they can then catabolize and convert to ATP when they need it. Now, some of your cells can get their energy from fats, but many of the most important ones, like your neurons and red blood cells, feed exclusively on glucose. So most of the carbs that your intestines absorb are converted to glucose for that reason. But if it's not needed right away, that energy can also get stored as glycogen in your liver and muscles, or converted to glycerol and fatty acids to make triglyceride fats. And even though there seems to be some kind of marketing war going on on against dietary fats. We most definitely need them. The fats in your adipose tissue store energy, of course, but they also store fat-soluble vitamins and cushion your organs. Lipids also form the myelin that insulates the neurons in your brain and throughout your body, as well as the oil in your skin, and they provide the vital calorie content found in breast milk. But there are other important lipids like cholesterol, which is the precursor to things like testosterone and estrogen, and of course phospholipids, which form the cell membrane in every single one of the 3 dozen or so trillion cells you have. Now, if you're into eating meat, a lot of the fat you ingest might come from that, but guess what? Plants have fat too. Plants use lipids for energy storage just like we do, except they do it in fruits and nuts and seeds, which, when you think of it, are kind of like plant breast milk. It's food for their growing babies. Either way, though, when you eat lipids, your body breaks down triglycerides into glycerol and fatty acids. Those molecules can then be processed and used in the making of ATP, or they might be converted into other kinds of fatty acids, which your cells can then reassemble into your very own triglycerides or phospholipids. And your liver happens to be great at converting one fatty acid into another, but there are some it just can't synthesize. For example, omega-6 and 3 fatty acids are called essential fatty acids because your body can't make them, so they have to be ingested. They get turned into all kinds of useful molecules like the ones used for synapse formation in the brain and for signaling inflammation during the healing process. But if carbohydrates provide energy and fats insulate and store energy, then just about everything else is done with proteins. They form the bulk of your muscle and connective tissue, but they're also what the ion channels and pumps are made of in your neurons and muscle cells, and they make up your enzymes, which are responsible for pretty much every chemical reaction in your body. In other words, your body runs on protein and pretty much is protein. Nutritionally speaking, meats, dairy products, eggs, legumes, nuts, cereals are all particularly high in protein. But because everything we eat was once alive and every cell of every living thing contains protein, as long as you're eating whole foods, you're at least partially restocking your protein supplies. It might seem like you have to eat muscle to make muscle or eat enzymes to make enzymes, but that's not how it works. Since all your proteins are made up of just 20 amino acids, the differences between the thousands of unique proteins are simply in the sequence of those amino acids. And of course, you have a specialized molecule that knows just which amino acids to put together in what order to make a certain protein. It's called DNA. When you consume some hamburger, for example, the protein actin in the meat gets catabolized into its component amino acids, which gets mixed up with all the amino acids from all the other proteins in the meat, like the collagen and elastin and chitin and myosin, as well as all the proteins from the bun, the tomato, and the mayonnaise. Those amino acids then get reassembled using anabolic reactions into your very own but somewhat different proteins as defined by your DNA. Each cell is like a picky little Gordon Ramsay, and it has to have every amino acid needed, every ingredient present before it will even think about starting to make a protein. And just like with your lipids, your cells can improvise and convert some amino acids into others if they're missing an ingredient. However, there are 9 essential amino acids that you cannot make from others and have to eat. Now, lots of foods don't provide every essential amino acid, but when you combine foods like beans and rice or pasta and cheese, you do get all of the essential amino acids, which is important because remember, after water, you are mostly made of protein, on the order of 16%. But what about the 1% of you, the carbohydrates? How that tiniest fraction of you ends up creating all the energy is what we'll discover next time. But for now, you've learned all about the vital nutrients, including water, vitamins, minerals, carbs, fats, and proteins, as well as how anabolic reactions build structures and require energy, while catabolic reactions tear things apart and release energy. And together, these competing forces form the wonderfully conflicted process known as metabolism. Thank you to our headmaster of learning, Linnea Boyav, and thanks to all of our Patreon patrons whose monthly contributions help make Crash Course possible, not only for Here's a couple of words you might find useful in the study of human metabolism. They also happen to be 2 words that I enjoy in general. Brunch, buffet. I'd throw in all you can eat, but that's kind of implied, and then it would be 6 words unless you hyphenate them. But still, brunch buffet. You got eggs and bacon and French toast and biscuits and fruit and some kind of weird sorted jello thing in there. And once you've paid your $12.99, you know there's a pretty good chance that it's all going to get eaten. But here's the thing. Not everything that you fit into your face during brunch time is going to be handled the same way by your body. After you're done digesting, some nutrients will go straight to your body's pile of stuff to burn right away, but others will have to be converted into something else. For example, the carbs and fats in your buttered toast can be directly oxidized into usable energy, but the amino acids in the bacon have to be converted into molecules that get broken down like carbs. carbs if you want to get energy out of them. And while excess carbs and fats can be stored in larger polymer versions of their original forms, any extra amino acids can't be. They have to be converted and then stored as fat or glycogen. So as I've mentioned before, the molecules in your body are constantly changing shape and renewing and rearranging themselves to either build things or to use energy. And eating food replenishes these nutrients, especially glucose. Then, depending on what your body needs and when you last ate, certain hormones like insulin will help decide what to burn and what to store for later. This, of course, is unimportant function, which is why things can go badly if this process doesn't work properly because of a metabolic disorder like diabetes. In that case, your body can't properly use and store nutritional energy, which makes the very acts of eating and metabolizing more difficult and possibly dangerous. Exactly how glucose levels can spike or plummet, how we convert nutrients into energy, and how all that relates to eating and hunger and weight, metabolism, and your health in general is, guess what? Complicated. But as you are a living thing that must eat in order to stay alive, I'd say it's worth learning how it works. And brunch is as good a place to start as any. For the all-you-can-eat brunch buffet is a good time to recall the law of conservation of energy. The law simply states that energy can never be created or destroyed, it can only change forms. The process of metabolism involves conversions of energy, either through catabolizing reactions that release the energy stored in your food, or anabolizing ones that use or store that energy. So you can enjoy your short stack of flapjacks and biscuits and gravy, but remember that energy has to either get released or stored somewhere inside you. Now, the conversion of food energy is part of the great balancing act that is maintaining homeostasis, and one of its greatest tricks is cellular respiration. Cellular respiration is how we derive energy from the food we eat, specifically glucose, which is where most of our food ends up. In order for glucose to become energy we can use, we have to give it some oxygen and convert each sugar molecule into 6 molecules of CO2 and 6 molecules of water, which usually produces about 32 molecules of ATP. Cellular respiration occurs in 3 simultaneous phases where glucose is broken down by glycolysis and other catabolic reactions, and then turned into pyruvic acid and acetyl-CoA, and finally ushered into the Krebs cycle. It's all pretty complicated, but we covered it extensively in Crash Course Biology, so rather than getting into the blow-by-blow here, I recommend you check out that video for a refresher. For now, just remember that cellular respiration breaks down nutrient molecules to generate ATP, and in doing so, it captures some of the chemical energy that was in those bonds for use in your body. Now, when it comes to how that energy is converted and where, that depends largely on when you ate your last meal. We all switch back and forth between 2 nutritional states, the absorptive or fed state, which is during or after eating, and the post-absorptive or fasting state, when the GI tract is empty and the body is running off of stored supplies. So say you're just post-brunch buffet and you're still in the absorptive state, unbuckling your belt as your digestive system breaks up the eggs and bacon and French toast and syrup into a bunch of mostly glucose molecules that pass into your bloodstream. The first bit of glucose gets delivered throughout the body and is tapped to generate ATP on the spot through cellular respiration. But since the meal was big and rich, there's more glucose floating around than your cells need at the moment. And remember, ATP is too unstable to be used for storage, which means all the extra glucose is going to get stored as fat or glycogen. And that storage is part of how you can end up gaining weight, because how much energy gets stored depends partly on your basal metabolic rate. That's the number of daily calories your body needs to do business as usual. And that rate can be influenced by your age, your sex, and body size or composition. A young bodybuilder is going to burn way more calories than that grandma, but generally, if you're absorbing more nutrients than you're burning, you will gain weight. So yeah, for that, you can blame the law of conservation of energy. Now, of course, all nutrients are important. I mean, your body is basically made of protein, so that's kind of key. But in terms of immediate fuel, glucose is the easiest source of food for cells like your neurons, and it's always a good policy to keep your brain well fed so it doesn't get hangry or dead. So your body likes to maintain a blood glucose level of 70 to 100 milligrams per deciliter. But let's say that thanks to the buffet, you've now got 140 milligrams per deciliter. This means too much sugar is swimming around in your blood and your body isn't happy about it. If your blood sugar levels get too high, it can damage blood vessels, especially those in the nervous system, heart, kidneys, eyes, and extremities. That's why diabetes is often associated with a higher risk of heart and kidney disease, loss of vision, and foot amputation. But typically, rising blood sugar levels sets off a series of events that trim them back down. Specifically, they trigger special beta cells in the pancreas to start secreting more of the hormone that regulates everything that happens when you're in the absorptive state. And this hormone is the all-powerful insulin. Insulin's job in this instance is to move glucose out of the blood and into storage. And to do that, it triggers a shift from catabolic reactions to anabolic ones. For example, it puts a stop to glycogenolysis, or breaking down glycogen in your liver and muscles to release glucose for energy, and instead ramps up the process of glycogenesis, where extra glucose is linked together to form glycogen. It also activates lipogenesis, where very cool chemical reactions in the liver can convert glucose to triglycerides and then ship them off to your adipose tissue for storage. A similar thing happens with the extra fatty acids that you got from the eggs and bacon that aren't immediately needed for energy. They get processed through lipogenesis too and are rebuilt back into triglycerides and then tucked away for a rainy day. The thing is, if you're thinking about this, all these lipids hate water, right? Fat and water don't mix. So you should be asking yourself, how can they be transported in the blood when they're so hydrophobic? The answer is lipoproteins, 4 specialized proteins made by the liver that surround fats and allow them to move in the bloodstream as an emulsion. You've probably heard of some of these. One is low-density lipoprotein, also known as LDL cholesterol. It's what delivers some of the glucose and fat that you just ate to your body's fat deposits. Another is high-density lipoprotein, or HDL cholesterol, which is the good cholesterol. It starts out as an empty protein packet sent out by the liver to gather up other cholesterols from the blood and artery walls and other cells. HDL then delivers the cholesterol back to the liver, or to places like the ovaries, testes, and adrenal glands, which use it to make steroid hormones. Alright, so now your body has put all the glucose and lipids and proteins where they need to go, and you can just coast into the post-absorptive state. So several hours later, even though your small intestine is still working on what's left of the buffet, your cells have been helping themselves to the remaining glucose in the blood, and eventually your blood sugar level will start to drop. Remember, your neurons are on an exclusive glucose meal plan, so they need sugar at the ready. And if your body senses an imbalance in blood sugar levels, it sounds the alarm. A decrease in glucose stimulates alpha cells in the pancreas to release insulin's nemesis, the hormone glucagon. It starts raising the blood sugar level by triggering the liver and adipose tissues to metabolize their fat and glycogen stores, thereby releasing fatty acids, glycerol, and glucose back into the blood. But if it's been a day or two since you've eaten, for some reason, you've burned through both your blood glucose and your glycogen stores, and you don't have any sugars left to feed your brain, in that case, your body will launch into gluconeogenesis and convert fats and amino acids into glucose, so ATP synthesis can continue in your brain cells. This process is a sort of last-ditch effort by the body to protect the nervous system from the damaging effects of low blood sugar. Now, of course, this whole system has its flaws, and one of them is that the whole setup is almost entirely dependent on the proper release and reception of insulin. People with diabetes either don't produce enough insulin or have abnormal receptors for it, which is why they often have to inject a pharmaceutical version of the chemical after eating. Otherwise, their blood sugar levels will remain too high, and they'll start peeing out large amounts of glucose to try and balance the levels in the blood. The problem is, because glucose is being excreted and not stored, it's not available when the blood sugar starts to drop, so the body has to draw on fat and protein tissues for energy, which is one reason why sudden weight loss can be an early sign of diabetes. Whether you're diabetic or not, I think we can all agree that it is important to respect your blood sugar levels and remember to continue feeding the beast. But at brunch, just, use small plates and try to keep the trips to the buffet line under 5 or so. Today, you learned how your body uses energy from food, including through cellular respiration, which converts glucose into ATP, glycogenesis, which converts it to glycogen, and lipogenesis, which converts it to triglycerides. And you also learned how insulin regulates your sugar levels. Thank you to our headmaster of learning, Linnea Boyd-F, and thank you to all.
Okay, good stuff? Interesting? Any questions about what you just saw? Did you guys eat breakfast today?
Oatmeal.
Very good.
It was packaged though, so don't toot my horn.
Nothing worse.
Actually, for some reason while I was watching him, all I could think of how interesting it would be to watch him and Sheldon from The Big Bang Theory have a conversation. Like I just was thinking, like, I just want to see that.
Squirrel.
I know.
Okay, so we talked about water last week. Water is necessary. It makes up, 60% of our body weight. Water is very main nutrients, okay, water, vitamins, minerals, carbohydrates, fats, and proteins. Okay, water has all those functions that we talked about last week and today. Vitamins help make use of our nutrients. Okay, we're gonna go through all the vitamins. There's vitamin C and all the B complex vitamins. Those are the water-soluble vitamins. And then the fat-soluble vitamins, the ADIC vitamins, A, D, E, K, are the fat-soluble. Okay, minerals, we talked a little bit about as far as fluid and electrolyte balance and the chemical signals that they give off. Okay, main functions of minerals in the body, they harden bones and teeth, specifically calcium, phosphorus, and magnesium. Okay, and then they balance our pH or acid-base balance, sodium, potassium, chlorine are main ones. And then action potential, okay, so the exchange between sodium and potassium and calcium across different nerve and muscle membranes, okay, stimulate the action that they're created to make. Okay, carbohydrates in their simplest form are broken down into glucose for our body to use for energy. Okay, fats and proteins also can be broken down and eventually turned into glucose for energy. Fats also make up glycerol and fatty acids. Okay, talked about how the phospholipids are part of that semi-permeable cell membrane, so all of our cells have some lipids in them. Okay, and then also the cholesterol from lipids, fats and lipids are the same things, right? They're the precursors to our sex hormones, estrogen and testosterone. Okay, and then protein are the building blocks, right, of our body. Simplest forms of protein after they're broken down are amino acids. It's kind of hard to see, that's kind of small. Okay, but you can indulge on occasion, right? But your diet should mainly consist of the following types of foods, okay, which is not very common in an American diet. Okay, whole grains, brown rice, oats, and quinoa. Does anybody eat any of that stuff ever? Some of you? Where I grew up, we only had white bread. Probably a lot of people grew up on white bread, but it's not very nutrient dense at all. It's mostly simple sugar. So the darker and the nuttier and the seedier the bread, the better it is for you. It's more nutrient dense. Okay, so for the amount of calories that it gives you lots of vitamins and minerals. Fruits are always good, berries, peaches, apples, pears, melons, bananas, grapes, etc. Fruits. Vegetables can be starchy or non-starchy. Potatoes are probably the most commonly consumed vegetable in the form of French fries. That's the least healthiest vegetable you can eat and the least healthiest way you can eat it. Okay, sweet potato fries are a big step up from regular fries because they're so nutrient dense. They're packed with good things for you, whereas the white potatoes are more of a simple sugar, lots of calories. Okay, non-starchy, your kale, spinach, peppers, zucchini, broccoli, bok choy, and Swiss chard, tomatoes, cauliflower. These are all good things that we should try to get on our plate. Okay, dairy products that are good are gonna be your plain yogurt. Okay, so if it tastes like sour cream, it's healthy. If it tastes good, it's not very healthy. So Trix yogurt is not as good for you as what's the good one now? Chobani is a pretty good one. They make almond milk yogurt now too. They make all kinds. So people who can't have milk and regular yogurt, they do make almond yogurt. Soy yogurt I've seen. Nuts like almonds, cashews are good. Fish and seafood. legumes are your chickpeas, beans, kidney beans, things like that. I got a good recipe. I already told you guys about it. If you've had buffalo chicken dip, which is amazing. Buffalo chicken dip, you've never had? So it's like shredded chicken, cream cheese, buffalo, sauce, mild is what I use, and then like cheeses, of course, and it's delicious. But in place of chicken, which is also like not super unhealthy, chicken's pretty good, but you can use like chickpeas or white beans, and it's really, really good. Especially like my husband's allergic to chicken, so that's how I found that recipe. I'm like, you have to try this dip, and it is pretty good. Eggs are good. Eggs sometimes get a bad rap because they do have fat and cholesterol, which we just saw are things that your body does need. So it depends on what else you're eating in the rest of the day. I mean, if the eggs are your fat and your protein and you're on mostly a plant-based diet, then you're good. Okay, if you're already getting, red meat and cheese and milk and fat from other places, then yeah, the egg is just gonna add to it. Okay, your healthy fats are your avocados and coconut oil, olive oil. Okay, different spices you can use instead of salt, herbs, and then your calorie-free drinks, water, of course. Black coffee or tea, once you add the sweeteners to it, it's not as healthy anymore, and then sparkling water, of course. Okay, and then the nutrition label is something that people really need more education on reading, because what is healthy and what is not healthy is just gonna depend on you and what you eat throughout the rest of the day. So if you can look at a label and see what's in it, then you're off to a good start. Okay, so there's always gonna be a serving size on the top. Okay, so maybe a container, like I got a thing of Junior Mints the other day. They're Easter themed Junior Mints, and I ate them all. And it's like 3 servings for 1 box. Okay, so all the, and it was, what I was reading, the total fat, the carbohydrates, which is sugar, right? They were like high enough just for 1 serving, and then I had to multiply it by 3, and that's how much I really ate. Okay, so it tells you your calories, again, per serving. So if it's not just an individually packaged something, you have to take into consideration how much you're eating. Potato chips, servings are usually like 12 chips, or something like that, and who eats 12 chips? I mean, what you're getting, you're gonna have to multiply by the actual serving size. Okay, fat, sodium, cholesterol, protein, carbohydrates is all standard on a food label, so all of that information will be there for you. It gives you the amount in grams, which is by weight. Okay, so, and you can look it up if you have a nutrition book, or just look up online. I'm eating, this much bread, this much chicken, how much is that? You can find that information. And then it gives you the percentage of a daily value. This one tells you on the bottom, it's based on a 2,000 calorie a day diet, okay, which is pretty standard. Okay, so less than that if you're a tiny person trying to stay tiny, more than that if you're a big, strong person trying to stay big and strong, or if you're a pregnant person who's growing a new human in your body, then you need more calories. Okay, things that we should avoid, which makes up most of our diet, probably. Okay, added sugars, agave you might use in baking, it's just liquid sugar. Okay, baked goods, which is so much of what we buy, or, a little snack muffin, or cupcake, or Ho-Ho's, Twinkies, anything like that. Ice cream, any candy. Okay, fast food, French fries, hot dogs, pizza, chicken nuggets. Right? Everybody loves chicken nuggets. Okay, processed and refined carbohydrates like bagels, white bread, crackers, cookies, chips, sugary cereals, boxed pastas, all of those things that we eat all the time really are on the bad list, not the good list. Okay, French fries, fried chicken, donuts, potato chips, those drinks that make up the majority of our fluid intake, right? Coke and Mountain Dew, sweet tea. Okay, and then diet foods you have to be careful of too, because of the artificial sweetener, may or may not be linked to cancer, right? not healthy if you drink 7 diet Dr. Peppers a day, okay? Just drink one good one and have the rest water. Nutrition, so poor nutrition, not enough nutrition, or too many of the wrong kinds of calories are going to impact wellness. Okay, so the essential nutrients that supply energy and build tissue are the macronutrients. So the carbohydrates, the fats, and the proteins supply energy and build tissue. Okay, so you are what you eat. Okay, the micronutrients that are in smaller amounts, vitamins and minerals, we consume those and they regulate and control body processes. Okay, they help us metabolize carbs, fats, and proteins. Energy in the diet is measured in the form of calories or kilocalories or CAL or a large C. You'll see they're all the same thing. Okay, and then the sources of calories are split into either a carbohydrate source, a protein source, or a fat source. Okay, so most all of the foods that we eat have carbohydrates, protein, and fats. Okay, some just have some. But there's lots of foods that you can get all 3. Okay. For every gram of carbohydrate, that provides you with 4 calories. For every gram of protein, that provides you with 4 calories. For every gram of fat, that provides you with 9 calories. Okay, so if you're making a meal and you measure out by weight and you can look up how many carbohydrates, proteins, and fats are in those foods, then you can figure out how many calories you're getting from that. Okay, this is not something that we do in nursing. Okay, we want to have a lot of knowledge about it, but it's really more enforcing and knowing the signs and symptoms to look for, or what to expect, kind of understanding physiologically what's going on in their body. Okay, but in the hospital setting, we do have nutritionists and dietitians that will do this kind of thing with the patient. Okay, they need specific education, that dietitian will go in there and give them dietary education. We're really more reinforcing and assessing, collecting data, making sense of the data that we see. Okay, so energy balance is calories in versus calories out. Okay, so the calories that you take in per day are going to depend on what you eat. Okay, the calories that you put out, okay, even if we do nothing, our metabolism, our body needs energy just to breathe and to digest our food and for our muscles to contract. So even if we're just resting, we need some energy just to carry on our processes that are occurring, maintaining temperature, maintaining your posture, all the secretions that are being released continuously in your body, propelling food through the GI tract, inflating lungs, contracting heart muscle. Okay, and then in addition to that, any other activity we do is going to burn calories as well. Okay, so what's coming in, what's going out. 1 pound of body fat equals 3,500 calories. So if you want to lose a pound of weight in a week, you would consume, a healthy way to do it would be 500 calories less per day, or burn 500 calories more per day, okay, if you wanted to lose a pound in a week. Things that raise your metabolism or make you burn energy faster are going to be times of growth. Okay, so little kids a lot of times can eat anything, right? Because they're constantly anabolizing or building new tissue. Okay, they're physically building and growing. Okay, so from infancy to adolescence to young adulthood, you're growing very quickly. Okay, so you need more calories. Metabolism is faster. Okay, so somebody who's very young can create more energy and use that energy quicker than somebody who is elderly. Okay, because they're not building new tissue anymore, they're not really growing anymore, notably, so they don't need as much energy. Okay, infection. If you have an infection of some type, your temperature will be higher, which increases your metabolism. Your body's trying to kill whatever is inside of it, so it's quick, it's sped up. Okay, emotional tension, stress. Okay, you can feel your heart beating faster, that's going to increase your metabolism. Extreme environmental temps, specifically heat, is going to increase. Epinephrine and thyroid hormones. Epinephrine is adrenaline, or the stress hormone, that fight or flight hormone. Thyroid hormones regulate growth. Okay, the elderly have a lower metabolism. They don't eat as many calories. Prolonged fasting is actually going to decrease your metabolism. It's going to work against you. So when you skip breakfast, you're actually making yourself more prone to developing diabetes. Okay, so those processes that we saw about glycogenolysis and gluconeogenesis, in our body that happens naturally, and we're supposed to get our steady meals throughout the day, and then aside from that, our body can tolerate and flex and supply us with what we need. If we skip a meal, then our liver is having to do things that it shouldn't normally have to do. Okay? It shouldn't normally have to provide us with energy by breaking down our glycogen that's stored in the liver and then converting that to glucose. Okay, so prolonged fasting, continued fasting is gonna mess up your balancing mechanisms that are built in place and can lead to eventual diabetes. All right, the BMI is the body mass index. This is the last slide we'll do before break. Yes. The BMI is the body mass index. It calculates if you are a healthy weight. It takes into account your height and your weight. There's calculators online. There's charts and graphs that you can look through. So I am 5'3" and a quarter, and right now, let's see, is that healthy? Okay, I'm healthy right now. Okay, so healthy is gonna be 18.5 to 24.9. So if you go along the side here, you can plug in your height, and then the top is your weight, and then you'll go down and find what your BMI is. Okay, once you get to the 25, that's gonna indicate overweight. Okay, the 30 to 39.9 is obesity, and BMI over 40 indicates extreme obesity. Okay, so overweight and obese are not subjective terms, but they are objective medical diagnoses. Okay, and once they get into this level BMI, they are at higher risk for type 2 diabetes, dyslipidemia, or atherosclerosis, hypertension, cardiovascular disease. Okay, below 18.5 is underweight, malnutrition, and we'll talk about what can happen with malnutrition. Okay, so 18.5, 24.9